Hi, this video is a short demonstration of the gsipdht2 application. If you're looking for more detailed information about the protocol or the algorithms, you can find them in the documentation and in internet drafts. So, when you want to play with peer-to-peer SIP overlays, the first thing to do is to create an overlay. You can do that simply running the gsipdht2 program and with one only parameter, which is a URL which will identify the starting node. So when we run the program, we see the user interface of the node appearing, and the user interface consists of several tabs. The main tab pretends to be a SIP user agent, even if it actually is only a messenger, because it misses the whole multimedia part. So when we have a client, when we have a peer, we can start a client. We can start a client running the gsipdht2 program again. We pass it this time an option specifying another port to bind. We specify the URL which will identify the starting client, and this time we specify one more URL which will be the URL of a peer in the overlay. In this case, there is only one peer, the overlay, which is bound on localhost on port 5060. So here we are. We have now a peer and a client. The user interface of the client is the same as the peer, except that it doesn't have functionalities which are peculiar of the peer. So we can start other clients to make the situation more interesting. We can do that using a shortcut provided by the spawn client menu. We can start client just selecting them from the menu. We can start as many clients as we want. So now we have one peer and 1, 2, 3 and 4 clients all running in the same overlay. The clients can act just as simple SIP user agents, so they can send messages. For example, node 5 can send message to node 2, and the message will be routed to the only peer of the overlay, and the peer will route it to the final destination. And we can see that a pop-up appears showing that a message, a SIP message, is being received. So to make the situation even more interesting, we can, well, first of all we have to find the peer. Okay, we can give a look at the internal state of the peer. This tab describes the state specified in internet drafts. But it is interesting that from the hash table part, from the keys part of the internal state, you can see the whole set of records stored in the local peer, and you can select a peer record, and right clicking on the entry, you can invite the peer. The invite menu pops up, and if you press the invite button, an invite is sent to the client, inviting him to join the overlay. Now we have accepted, and we have an overlay made of two peers. We can see this in the 2D tab, which provides a geometrical representation of the CAN space. Now let's invite some other peers, some other clients to join the overlay. So for example, node 2 is not a peer yet. We can invite it. When it accepts, yeah, we can see the situation is changed here, but it's changed also on all other peers. So let's see what happens when a peer dies. After, okay, we can see some debug information in the in the shell where we started the first peer. So after a timeout, the takeover algorithm should start. It has started. It started now. Okay, so the most appropriate peer has just taken over the orphan zone. So the most appropriate was node 0. And now node 0 is authoritative also on the zone which was left uncovered by the dead node. So I think it's enough for now. Just go and download it and install it and play with it. Thank you very much.